Okay, so now we have enough theory to start looking at why this is an example of an exothermic reaction, or why this reaction is exothermic. So why is that an exothermic reaction, and why is this reaction that we looked at an endothermic reaction? So what is it that makes this an endothermic reaction and this one an exothermic reaction? So let's start with the exothermic version first. Let me just slot this in. Maybe I can't slot it in. Okay, so why is this one an exothermic reaction? If we look in a bit more detail then about the reaction here, so making 2HCl, we've got hydrogen, so we've got two hydrogens joined together, so that little dash there is representing a bond. So we've got two hydrogens joined together, they're reacting with two chlorines which are joined together, so there's the two chlorines joined together, and they're making, so those two are then making two HCl's, there's one, so a H and a Cl joined together, and another one, a H and a Cl joined together. So that's what's actually happening in my reaction. These two bonds here are being broken, and these two bonds here are being made. So if I just quickly sketch the energy profile again, I won't label it. So the reactants, this is one of the reactants, there's the other one. The bonds there are being broken, and then these bonds here are being made. Now we can think slightly differently about the energy profile. In order to get the reaction to work, I need to break that bond and that bond. So break bonds. Those two bonds need to be broken, and then by the time the reaction's finished, I also need to have made these two bonds here. So I need to make those two bonds there. Now in order to break bonds, so in order to break these two bonds, you need to put in energy to get them to break. So bond breaking requires energy. So bond breaking requires energy, and then in order to make bonds, so bond making releases energy. So in order to get those bonds to break, I need to put in some energy, and then when I end up making those bonds, it's going to release energy. I can label those ideas on my energy profile. So this gap in energy here going up from the reactants to the top is the energy for bond breaking. So there's my reactants. If I throw that much energy at them, I'm going to break all of those bonds. It's the same energy gap as it was for activation energy. So the bond breaking value is the same as the activation energy value. Then what happens once I've broken all the bonds is I'm going to make all of the bonds here. So making bonds. So bond breaking requires energy. It takes in energy to break the bonds, and then it releases energy when you make the new bonds. That's what's actually happening in this reaction. And then we said previously that this gap here is the energy change in delta H. So I said at the start of this we're going to talk about why this is an exothermic reaction, and we can do this now. So this is an exothermic reaction, which means delta H is negative. The reason for that is because the energy that you need in order to break the bonds there is less than the energy that we get released when we make all of the new bonds. So in more simple terms, this number here is bigger than this number here. So exothermic because the energy released when making bonds is bigger or is greater than the energy taken in when breaking bonds. So you can think of it simply as the reason this is exothermic, the reason the energy change is negative, the reason why products are lower in energy than reactants is because that number is bigger than that one. But that is the key idea. You need to be able to use that in exam answers. So exothermic because the energy released when making bonds, when we make these bonds, is greater than the energy taken in when we break these two bonds over here. So we'll do the same now. We'll look at it, the opposite story, but for endothermic energy profiles. So where did I put that? There it is. So endothermic energy profiles now. So there's my endothermic reaction from before. It could have been another one, but that's the one that I chose, and we said delta H was positive. So if we redraw the endothermic energy profile, it's going to look something like that, where time is on the x-axis and energy is on the y-axis, saying kilojoules again. So products have more energy than the reactants because the chemicals are taking in energy as the reaction goes on. Now, in order to get this reaction to work, I've got to break all the bonds in that. So this gap here, same as the activation energy, this gap there is the bond breaking energy. So that's the energy that we need to break the bonds. And then once I've broken all of those bonds, I need to make all the bonds that we've got in here. So I make these bonds here. So this is bond making. And we said that delta H is positive in this case. So the energy change is positive. So why is the energy change positive in these type of reactions? Why are the reactions endothermic? In this case, so endothermic, so if I just show you exothermic again, exothermic because the energy released when making bonds is greater than the energy taken in when breaking bonds. So because that much, the number for that value there is bigger than the number for that value there. In an endothermic profile, hopefully you can see that that's the opposite is true. So the bond breaking energy is much greater than the bond making energy. So endothermic because energy released when making bonds is less than the energy taken in when breaking bonds. So that's the key idea for endothermic. So in endothermic reaction, delta H is positive. The reason delta H is positive is because we take in that much energy. So we take in a load of energy in order to break all the bonds, but only that much energy gets released when we make the bonds. So the products end up with more energy than the reactants, and therefore delta H is positive. I get that that idea is hard to understand, but it's an important idea, and if you can get the marks in those for those past paper questions, then you'll be on to a bit of a winner in terms of answering questions that other people won't be able to get.